So, in the yesterday's lecture, we have discussed the two types of quantum numbers. That is, first one, principal quantum number, and second one, azimuthal quantum number. The characteristics of principal and azimuthal quantum numbers. That is, the first quantum number, that is called principal quantum number, gives number of main energy levels and size of the electron cloud. These are the two important characters of principal quantum number. The second quantum number, which gives the more perfection in the position of an electron, is nothing but azimuthal, or it is also called orbital quantum number. So it gives number of subshells present in the main energy level, or it gives number of sub-energy levels present in the main shell or main energy level. And most important character of azimuthal or azimuthal quantum number is that this azimuthal quantum number gives the shape of the electron cloud or shape of the orbital. First of all, that is shape of S orbital is spherical in nature, and shape of the P orbital is dumbbell shaped in nature. So dumbbell shaped is the shape of P orbital, and spherical is nothing but the shape of S orbital. And that's why this quantum number, which gives shape of the orbital, hence it is called orbital quantum number. So this is all about principal quantum number and azimuthal quantum number. And this is we studied these two concepts or these two articles, questions in yesterday's lecture. Now in today's lecture, the third quantum number, which is called a magnetic quantum number, it also gives the exactness or the perfect position of an electron in main energy level, in sub-energy level, and in sub-energy level there are orbitals, or there is a presence of orbital in case of magnetic quantum number. So this quantum number, first of all, gives the orientation of an electron. What do you mean by orientation? Orientation is nothing but the rotation of an electron or spin of an electron around its own axis in a clockwise and anti-clockwise direction. So this is called orientation. Orientation is nothing but the momentum or a rotation or a spin of an electron about its own axis is called orientation. So the first important point regarding this magnetic quantum number, which gives most correct position as compared to most correct position of an electron as compared to principal and azimuthal quantum number. So this quantum number, that is a magnetic quantum number, gives orientation of an electron cloud or orientation of an electron about its own axis. This is the first point. What is the second one? This quantum number gives a number of orbitals. This is the perfect position, or this is the position of an electron in the sub-energy level, or orbital is nothing but the space or a region in sub-energy level, that is called orbitals. So this magnetic quantum number gives a number of orbitals present in the sub-energy level. This is the second point regarding this magnetic quantum number. The third one, this quantum number, that is principal, is denoted by N, azimuthal is denoted by small letter L, and this quantum number, that is called magnetic quantum number, gives or denoted by a small letter m. So the fourth point regarding this, what is the difference between orbital and orbit? This is a most important point regarding this magnetic quantum number. What is meant by orbit and what is meant by orbital? This is the most important question. What is called orbit and orbital? Orbit and orbital. So what is orbit? This orbit is nothing but the fixed circular path around the nucleus. Orbit is the fixed circular path around the nucleus in which electron revolves is called an orbit. So orbit is the fixed constant circular path around the nucleus of an atom in which electron revolves is called an orbit. So what is orbital? Orbital is nothing but the space around the nucleus also, the space in the main energy level, space in the sub-energy level, or in simple words, orbital is nothing but the space or region in the sub-energy level around the nucleus at which there is a maximum probability of finding the electron takes place is called an orbital. So what is orbital? Orbital is nothing but the space in the sub-energy level or the region in the sub-energy level around the nucleus in which there is a maximum probability of finding the electron takes place is called an orbital. So this is all about orbit and orbital, and the concept of orbital is studied by this magnetic quantum number. So this is all about orbit and orbital. The values of magnetic quantum number are calculated by the formula m is equal to 2l plus 1. So m stands for magnetic quantum number, L stands for azimuthal quantum number. So this equation, this formula shows that m is equal to 2l plus 1. So whatever may be the value of m, so m gives number of orbitals present in the subshell. M gives the value of m is nothing but the number of orbitals present in the sub-energy level or a number of orbitals present in the subshell. That is called m. So m is equal to 2l plus 1. L stands for value of azimuthal quantum number. In yesterday's lecture, we calculate or we have the values of azimuthal quantum number, that is L is equal to 0, 1, 2 and 3 respectively. So 0, the value of L is equal to 0 means S subshell. Value of azimuthal quantum number, that is L is equal to 1, represents P subshell or P sub-energy level. L is equal to 2 denotes D sub-energy level or D subshell, and the value L is equal to 3 represents or denotes F sub-energy level. So 0, 1, 2, 3 means S, P, D and F respectively. So from this formula we can calculate the values of m, that is number of orbitals present in the sub-energy levels, that is S, P, D and F respectively. It means that it also, we conclude on this particular formula, that is m is equal to 2l plus 1, it self indicates that the values of magnetic quantum number totally depends upon values of azimuthal quantum number. As we mentioned in the yesterday's lecture, values of azimuthal quantum number totally depends upon the values of principal quantum number. It means values of L depends upon values of N. Similarly, values of M, that is magnetic quantum number, depends upon the values of azimuthal quantum number or orbital quantum number, that is L. So this is all about M is equal to 2L plus 1. What is the fifth one? The values of magnetic quantum number lies in between minus L, 0 to plus L. Minus L, 0 to plus L. So what is minus L dash 0 dash plus L? So these are the values of magnetic quantum number lies in between these values. So what is minus 1? Minus L, 0 to plus L. We know that electron rotates about its own axis in two different forms or two different ways, that is in a clockwise direction. Momentum of an electron in a clockwise direction is denoted by the value plus L, whereas the momentum or spin of an electron in an anti-clockwise direction is denoted by the value of minus L, and that's why values of magnetic quantum number lies in between minus L to 0 to plus L. As we mentioned before, the values of magnetic quantum number depends upon values of azimuthal quantum number L. So by considering all these points, it is very easy to calculate number of orbitals present in the sub-energy level one by one. So we know that L is equal to 0. As we mentioned before, L is equal to 0. It means this 0 values represents S sub shell or S sub energy level. And M is equal to 2L plus 1. It gives number of orbitals present in the sub energy level. So L is equal to 0. So put L is equal to 0, that is number of orbitals present in the S subshell can be calculated. M is equal to 2L plus 1. Put L is equal to 0. M is equal to 2 multiplied by 0 means 0 plus 1, that is M is equal to 1. So first value of M is nothing but 0. That's why M is equal to 0, which represents S orbital. So first value of M is equal to 0. There are number of orbitals in S subshell are 1 in number. 1 in number, there is only one orbital is present in case of S subshell. So S subshell contains only single orbital, that is called S orbital, which contains, or each and every orbital contains a maximum 2 electrons only. So the capacity of S subshell, as we mentioned in azimuthal quantum number, is nothing but S subshell accommodate. S subshell only captures or occupy maximum number of electrons is equal to 2. So as a subshell contains only 2 electrons, hence number of orbitals present in the S subshell is definitely equal to 1, and that's why M is equal to 1. But the first value of M, that is values of M, are lies in between minus L, 0 to plus L. Hence the first value of M is equal to 0. M is equal to 0 means S orbital. So this is all about first value of L. L is equal to 0. Now put L is equal to 1. So 1 represents P subshell. 1 represents P subshell. Put L is equal to 1. So when we put L is equal to 1 in this formula, 2 multiplied by 1, that is 2 plus 1, is equal to 3. M is equal to 3 means there are 3 orbitals. So 3 orbitals, that is M is equal to 3. There are 3 orbitals. So the values of m, that is number of orbitals present in p subshell are 3 in number. So m is equal to 3. Number of orbitals are 3. So these orbitals are px, py, pz, or it is according to the electronic configuration, it becomes 2px, 2py, 2pz, or 3px, 3py, 3pz, or 4px, 4py, 4pz, and so on. So m is equal to, m has 3 values, that is number of orbitals present in the p subshell are 3. So values are 3. 3 orbitals are present. These 3 orbitals are px, py, and pz. So the values are denoted by -1. So first value 0, +1, -1. m is equal to -1, 0, +1. So this is px, py, and pz. Similarly, L is equal to 2. So L is equal to 2 means D subshell or D sub energy level. So number of orbitals present in the D sub energy level. So when we put L is equal to 2, that is equal to 4, 4 plus 1, that is equal to 5. M is equal to 5. There are 5 orbitals in the D subshell. 5 orbitals means number of electrons is equal to 5 multiplied by 2. So 5 multiplied by 2 is equal to 10. So D subshell contains maximum 10 electrons and 5 orbitals are present in it. So M is equal to 5 orbitals are present. So the values of magnetic quantum number are -2, -1, 0, +1, and +2 respectively. So this is all about the values of number of orbitals present in the subshell. S subshell are 1, so maximum electrons are 2. Number of orbitals present in p subshell are 3. So number of electrons, maximum number of electrons present are 3 multiplied by 2, that is 6. L is equal to 2. Number of orbitals present in case of D subshell are 5. So number of electrons is equal to 5 multiplied by 2, that is equal to 10. And the values are M is equal to -2, -1, 0, +1, +2. This is all about the values. In case of L is equal to 3, means F subshell. L is equal to 3 means F subshell. F subshell, put L is equal to 3, that is for F subshell. 3 multiplied by 2, 6, plus 1, that is 7. 7 orbitals are present in case of F subshell. So as 7 orbitals are present, each orbital contains maximum 2 electrons. So 7 multiplied by 2, that is equal to 14. So F subshell contains maximum 14 electrons. So yes, number of orbitals is equal to 1, number of electrons is equal to 2. For P subshell, number of orbitals are 6. Number of orbitals are 3, maximum number of electrons is equal to 6. In case of D subshell, number of orbitals are 5 in number. Maximum number of electrons present is equal to 5 multiplied by 2, that is 10 electrons. And in case of F subshell, number of orbitals are 7 in number, and that's why number of electrons present is equal to 7 multiplied by 2, that is 14 respectively. So S, P, D and F contains 1, 3, 5 and 7 orbitals respectively. At the same time, D subshell contains maximum electrons 2, 3, 5 and 7 orbitals respectively. So this is all about magnetic quantum number, characteristics and the values of magnetic quantum number on the basis of information about the number of orbitals and orientation of an electron. बघू